So what I wanted to do today was to kind of review all the different types of graphs that you'll see. We're only going to talk about constant velocity and changing velocity, but when we're talking about changing velocity, it's only going to be constant acceleration. It'll make more sense as we do it. So here are a set of 3 companion graphs. So we have displacement versus time, we're going to have velocity versus time, and then acceleration versus time. So remember, time is always in seconds. And I'm drawing them kind of near each other. We're going to make them related. Displacements in meters, velocities meters per second, acceleration meters per second squared. For units, this is going to be our 0. I'm going to make it pretty easy. This is going to be positive, negative, positive, negative. So we could kind of just say this is going to happen for all. We're not going to talk about specific numbers, but in general, this will work for kind of different types of numbers that you'll have. So right now, we're going to talk about a situation that is no velocity. So that means v equals 0. So if v equals 0, that means we're going to have a line straight across. That's a really ugly line straight across, but a line straight across. I cannot do it. A line straight across. Okay, let's just say that has a slope of 0. It doesn't matter where it is. It could be there. It could be down here. It could even be on the 0 itself. Okay. When you have this, here our slope is going to be equal to 0. So that means you have a velocity. Remember, slope of a d versus t time. Is equal to velocity. So what we have here is that if it's 0, it's going to be 0. So that means our velocity graph is going to be 0. That means our acceleration graph is going to be 0. So when you have no velocity, it could be above the x-axis, on the 0, below the x-axis, but then the other two, both velocity and acceleration, must be on the x-axis for 0. So those are your answers. So if you have something that's not moving, this thing could be anywhere, but it's a horizontal line. These have to be here. All right, next. So what happens if we had, I'm going to do really fast, and this time I'm not going to label the units just to save on time. Let's say something is, and this time the situation, that's really ugly, sorry, let me kind of get rid of that. Let's say the situation this time is constant positive velocity. Okay, so when you have a constant positive velocity, let me change the color. That means that, remember, positive, 0, negative, positive, 0, negative, positive, 0, negative. All right, so if it's up here, what does that mean? Well, in our displacement versus time graph, that means we have a positive slope up there. Slope positive, which means velocity is forwards. Okay, or up, depending on whichever way you have positive. Now, this could be like this. It could be like this. Doesn't matter where the start position. Remember, these are just start positions. It doesn't really matter. It just all that matters is the slope has to be positive. So if the slope's positive, that means it's moving at constant speed. Constant speed because it's a line. That means acceleration, though, is still 0 because the slope of this is still equal to 0. Okay. Last situation when we have constant velocity. And that last situation is if we have a constant negative velocity. So that means you're going velocity. So that means you're going backwards. D versus T, V versus T, A versus T. That means you're going backwards. Okay, down. Like I said, it could be down here, it could be up here, it doesn't really matter. All that matters is that the slope here is negative, and it's a line. Okay, so that means if this was plus 0, negative, that means my velocity graph will be down here somewhere, but my acceleration is still 0. So remember, when we have constant velocity, our acceleration graph is always going to be 0. And the velocity graph is always going to be a horizontal line. So if you have a straight line in displacement versus time, you're going to get a horizontal here and there. So we had 3 situations already. So all these are for constant velocity. Now, what happens if we have changing velocity? Okay, we're going to have, that's really ugly, changing velocity. Okay, we're going to have 4 different situations. The first one is forward, slow to fast, or acceleration, positive acceleration. So the most classic example is the first thing that we did in class, which is a rocket that's blasting off. So if a rocket's blasting off, the displacement versus time graph is going to kind of look like a rocket blasting off. Now, I'm not going to redraw this in 3 separate ways because I think it'll get too confusing now, but just know, once again, it could be here, it could be up here, it doesn't really matter. It just know all that matters for displacement versus time is the slope. So when we're looking at this, and this is kind of the trick here, is we want to look at what's happening. I'll do gray. What's happening as it goes up. So if I drew tangent lines, let's draw 3 tangent lines. Let's do one in the beginning, one in the middle, and one in the end. So if we drew one here, one here, and one here. Let's talk about their differences or similarities. Here you'll notice that they're all positive. Okay. You're going from small to big to biggest. So if you want, you could put numbers on it. 1, 2, 3. Slope of 1, 2, 3. So here we have all positive and they're increasing. So you're going from slow to fast, positive acceleration if that's the case. So positive, 0, negative. If you want, you can make it a little bit easier for yourself. 1, 2, 3. So at the first time it was at 1. The second time it was at 2. The third time it was at 3. And we're going to have a best fit line and you're going to get that. So in a curve that looks like this, my velocity versus time graph is going to look like this. The slope of this is going to be positive, so it's going to be above the x-axis. So if you have a curve that goes up like this, acceleration from slow to fast, you're going to have a positive velocity and then a 0 but positive acceleration. So here the slope is increasing. Here the slope is 0 but still positive. Okay, that's the first situation. Second situation. We're still going to have positive velocity. But this time we're going to go from fast to slow. So I guess the best way to explain this is if you're going fast to slow, is a bungee cord is one way, or you're in your car, you're driving at 40 miles per hour, you slam on your brakes, you're going to come to a stop. So those are going fast to slow. And when you do that, your graph is going to look like the following. Fast to slow, but positive. Okay, so notice that I am always going forward, and I know that because if I did do the whole slope thing again, take 3 slopes at 3 different spots. Here's 1. Here's 2. Here's 3. All my slopes are positive. So that means I'm moving forward, but I'm decreasing. Let's make up numbers again. So this one is the biggest. This one's just normal. And this one's the smallest. So you're decreasing in size. And I'll make up numbers again, 3, 2, 1. So you're going 3, 2, 1. So you're going from fast to slow. Now you're going deceleration. I think that's how you spell it. Okay. So if you're doing it here, positive, 0, negative, 3, 2, 1. The difference is before we started at 1, here we're going to start at 3, 2, 1. Now, you have to be careful on this. This graph does not go below. Once it passes that point right there, that means you're moving backwards. We never go backwards here. So, there we go. So it's only from here to here. Now, does it hit the 0? We don't know. I mean, technically, if I drew this correctly, that might have been a 0, but we don't know. Here, it is a negative slope, so it's going to be down here. Positive, 0, negative. So when you look at this, even though you're going forward, the velocity is always positive, and acceleration is negative. So you have to be careful. Even though acceleration is negative, it doesn't mean it's not going forward. It could be going forward. In this case, it's just braking. 2 more left. Now, the last 2 were going forward. Now we're going to go backwards, or negative velocity. And it's the same 2 combinations. Fast to slow, slow to fast. So let's do fast to slow first. So, negative velocity, fast to slow. So it's going to look like this. And let me do a better color. So if we did the same thing, we got a bunch of lines here. Here's 1. Here's 2. Here's 3, kind of test slopes. You'll notice that all these, I could have done that one better, but all these are negative slopes. And you're going from big, normal, to small. So make up numbers 3, 2, 1. But all these are negative. So if I'm doing my velocity versus time graph, and positive, 0, negative, here's 1, 2, 3, and then negative. We start off with 3, 2, 1. There we go. Make sure, once again, you don't cross that line, because once you cross the line, that means you went forward. And we didn't go forward. At least the graph doesn't show us that we went forward. Here we have a positive slope, so acceleration's up here. Okay, so yes, we have a positive acceleration because when we talk about forces, the force is the opposite direction of the speed. So you're going down or forward or backwards, and the acceleration is the opposite direction, so it's going to be the opposite. The last one is you have, once again, negative velocity. But this time we're going from slow to fast. Okay, slow to fast. So let's do it up here. Actually, we don't have to. We could do it down here as well. Okay, yeah, I could have done this a little better. But anyway, same thing. Break it out. So yeah, I want to do slope here, slope here, slope here. The first one will be like that. The second one will be like that. And last one will be like that. Once again, they're all negative. You're going from small to biggest, so -1, -2, -3. So if I labeled it here like that, 1, 2, 3, you're going to go 1, 2, 3. So it's going to look like that. And your acceleration is going to be negative. This should look familiar. This is the graph we did on Friday. This is something falling. Okay, so you have it this way, and then you have a negative velocity, and then you have that. So when something's falling, it should look like that. All right, so hopefully that makes sense. I'll also post up a cheat sheet kind of summarizing everything here, and we're going to do some matching today.